Uh, Today I would like to little bit talk about some opportunities and challenges of Benchtop NMR, and just to give you a short report of what kind of works are already being done with this kind of NMR instruments. So as you all know, NMR has some advantages and some disadvantages. So compared to other chromatographic systems, NMR is rapid, robust system, and especially we have node separation or derivatization in here. And the problem, maybe the limitation with NMR would be the low sensitivity of NMR, big footprint of the instrument, the price, and yeah. So that's why compared to GC and LC are actually mass spectrometric systems, it has some advantages and some limitations. So Benchtop NMR has recently emerged as a portable NMR system. So they can bring about many of the advantages of NMR, but two of the main disadvantages of NMR, which are high cost of the instrument and also the portability of the instrument, would be resolved in this kind of instrument. But we know the sensitivity would be much higher than the big NMR instrument. So we want to see what kind of works can be done by this generation of the NMR instruments. So at this time, we have about 6 or 7 industrial producer of benchtop NMRs. So Bruker is producing 80 megahertz instruments. Magritek producing 60, 80, 90 instruments. NanoAnalysis is producing 60 megahertz and 100 megahertz. Oxford Instrument as well, Thermo Fisher producing 80 and 45 megahertz one, and also Magnetics is producing the most powerful benchtop NMR, which is 125 megahertz instrument. Each of these instruments have their own characteristics, sensitivities, limitations. Some of them have auto samplers, some of them have solvent suppression system, some not. So depends on the application. Some of them may be useful for us or not. So the important thing about these time domain NMR is they are actually very low sensitivity instruments. So a good combination between chemometrics methods, different algorithms like MCR or other things are actually needed to overcome this problem. So to commercialize this kind of instrument, an indispensable approach would be combination of this instrument with chemometrics methods. So I'm going to quickly talk about some of the papers which are already being published on different aspects of application, especially in industry. So I will be talking about food chemistry, application of benchtop NMR, its application in pharmaceuticals, and disease monitoring and point of care applications. First of all, it's been widely used in wine industry. So for geographic indication of wine and determination of origin of wine, which is a very important factor in this industry. So we have different kind of markers, different kind of acids, alcohols and sugars. And there are many papers that acids like lactic acid or ethanol, succinic acid, malic acid, glycerol, or fructose, glucose are being very well identified for classifications of wine based on benchtop NMRs. Also, benchtop NMR has been very well applied for different kind of drinks. So for metabolite profiling of drinks, and we can use this instrument as well. So here you can see sucrose, glucose, fructose, caffeine, aspartame, citric acid, glycol, ethanol can be very well identified for classification and other QC purposes of drinks as well. The other important things is application of this instrument for determination and quantification of cannabinoids. So at this, I think the analysis is has already developed an algorithm for on-site quantification and quality control of cannabis, like right in the field to determine the most important metabolite, which are THC and CBD, and these are actually the most valuable the metabolites that the cannabis industry rely on. So you see that we don't need big, expensive instruments for this kind of analysis, and most of these applications are actually industrial applications. So maybe by having a low cost of like 20 or 50K instrument, all these analysis can be done by the customer. The other interesting report I found was about meat authentication. So in 2013, there was a big fraud in food industry in which it was understood that horse meat was being widely processed, distributed in processed meat in Europe, especially in UK. So there has been many methods for detections of this kind of fraud. Many of them have been relying on DNA-based techniques, but as you see in this picture, there are very good markers which analyze different kinds of beef, horse, or pork from each other. So this is definitely much easier, much more applicable, and cheaper uh, technique compared to DNA-based analysis. Also, for vegetable oil analysis industry, this analysis can be very well applied. You see that in this technique, maybe we need to do 2D NMR, and sunflower, olive flower, peanut flower oils can be detected from each other. So sometimes we need to do 1D NMR, sometimes we need to do 2D NMR, but at the final point, they are applicable for differentiation of the sources of the products. Here's a list of the benchtop NMR, but I will be talking a little bit about this interesting paper. So in 2016 in Taiwan, there was another fraud in coffee industry. So a company tried to mix Robusta coffee with Arabica coffee. So Arabica coffee is a much more expensive compared to Robusta coffee. So actually, from that time they decided to have a continuous way to monitor this process to prevent this kind of frauds. And as you see, 16O-methyl caffeistol at the 3.2 ppm, I marked it with that green flash over there, is the only marker which differentiates between Robusta coffee and Arabica coffee. So Arabica coffee doesn't have this marker, but Robusta coffee has this marker. So using this marker, we can quantify these two from each other, and the percent of illegal mixing these two together, because they are supposed to be pure things from each other. So NMR has been very well applied in this case as well. So let me go to the other one. Okay, so we are definitely interested in metabolomics-based work with NMR, with NMR. So I found actually just couple of papers on this, and I told you about two of them. The first of them is tuberculosis research. You know, tuberculosis is one of the main causes of death in poor countries. And one of the only ways to detect this is by culture of the bacteria causing it. This culture takes maybe 4 to 6 weeks, and we may lose the window to treat people. Here there is a report, and we can see Benchtop NMR as a cheap and available method, can be very well applied for metabolic profiling of the ill people, and it can be well applied for understanding the progress of the disease. I think this paper was published in 2021. The other work, which is a case of point of care and can be applied for the monitoring of the treatment for diabetics disease, is application of this kind of NMR for profiling of these metabolites of diabetes. So you can see different metabolites of aromatic compound, about 15 aromatic compounds, 6 glucose, and some other amino acids, organic acids. And some other ones like 15 or 19 metabolites can be very well applied, can be very well analyzed to differentiate between healthy and unhealthy people, and to monitor the progress of the treatments and the progress of the disease. So yeah, these two papers I found about metabolomics and point of care of Benchtop NMR. So I'm done with my short talk. Hope you liked it. And yeah, I will be happy if you have any question.